All right, this is lecture 3.7a, because we're going to break this up into um, two lectures, 3.7a, quadratic inequalities. So essential standard is I can graph with labels and scales quadratic inequalities, and I can solve these quadratic inequalities. Quadratic inequalities with two variables, x and y, are graphed with the same basic process as linear inequalities with two variables. The curve is graphed with a solid or dotted line as appropriate, and then one-sided is shaded. So you have some experience with graphing inequalities. So we're going to do the same thing, except now it's a quadratic instead of a linear equation. Now, this is actually a really good time, in my opinion, to uh, talk about some of the things that we've learned, because what we're getting ready to do is going to be a really good review of all of our forms that we have been taught for a quadratic and how to graph them. So I'm going to take a minute to actually review those forms. We have our standard form or expanded form, ax squared plus bx plus c. And if we recall, what is the vertex, the x coordinate of the vertex is equal to minus b over 2a. So we can find the x coordinate of the vertex in that way, and we can find the y coordinate by plugging that value in, and now we know the vertex. Then we have a factored form, which is x minus p times x minus q. And that will quickly give us the x-intercepts. And that is P and Q. So if you set that equal to 0 and solve for x, you would find that x is P and Q to satisfy, that's where the graph will cross the x-axis when y is equal to 0. Now, how do I find the vertex in that situation? Well, we can find the x-coordinate of that by taking the midpoint between P and Q. So how do I take the midpoint? I basically add P and Q together and divide by 2. So that is the x-coordinate of the vertex, and then I can plug that back into the equation and find my y-coordinate of the vertex. And the last one is the easiest one to actually graph, which is in vertex form. And the vertex then becomes is h and k. Be very careful of this notation here. So if h is positive, if it's minus 3, for example, then 3 is the value of h. If it's plus 3, then it would be negative 3. Okay, in all cases, if a is greater than 0, so it's a positive value, the parabola will open up. If a is less than 0, the parabola will open down. Now, in addition to that, notice that a is outside of the function. And so we have learned how to do vertical and horizontal dilations. And since a is outside of the function, based on that, we can actually use our dilations that we practiced at the beginning of this unit to quickly graph if we have mastered that. And that is actually a really powerful tool. So I encourage you to continue to do that. Okay, so let's do the problem. So that was a quick review. So we have, the instructions are graph the quadratic inequality, find the vertex, and the most appropriate method based on the equation type. So based on the fact that we have this equation, y is less than 2x squared minus 8x plus 3, that is in standard or expanded form. And the best way to graph that is to find the vertex. The x coordinate of the vertex is equal to negative b over 2a, which is positive 8 over 2 times 2. And so we will get the x coordinate of the vertex is 2. Now, how do I find the y coordinate? This is just a fancy way of saying y. Y is equal to what when x is 2? So I get 2 times 4 minus 8 times 2 plus 3, and I will find that value to be negative 5. So the vertex coordinates is at 2, negative 5. So let's go and plot that. Vertex 2, negative 5 will give me this location right here. Okay. All right. So there's my vertex. Now what do? Well, let's take a look at A. A is greater than 0 because A is equal to 2. So we know that the parabola opens up. Now, the other thing that we can notice is that we have a vertical dilation of 2. So if it's a parabola, and we would have expected it, if you recall, if I went over 1, I should have gone up 1. If I went over 2, x squared, I would have gone up 4. But in this case, each output is going to be multiplied by 2. So instead of going over 1, up 1, I'm going to go over 1, up 2. Instead of going over 2, up 4, I'm going to go 2, up 8, which gives me a positive 3. And I would do the same on the other side. Okay, and we would then notice that we have a y is less than, so we have a dotted line, not a solid line. So do your best. Okay, now if that is giving you heartache, the other way to potentially graph this is to say, what is y when x is equal to 0? So plug in 0 for all of your x values, and you will find that y is equal to 3. So we can come and find this point at the y-intercept and then use symmetry. So if I went over, so here's my line of symmetry. If I went to the left 2 at that location, then I would go to the right 2 at that location. Now it's best to have um, more than one, let's say 2 points on each side. And when you use your dilations, you can actually do that. However, 1 point is acceptable, and you can use your y-intercept to actually accomplish that rather quickly. Now we're not done. We've been asked to graph this, and we have graphed the function, but we haven't shaded in our solution region. And since it's less than without an equality, the entire region below the graph is our solution set. Okay. All right. Next, once again, this is in standard form, and so the method that you would use is to find the x coordinate of the vertex. So what is the x coordinate of the vertex? It is equal to minus b over 2a, which is equal to minus 2 over 2 times a fourth, which is negative 2 over 1/2. I got to get rid of the 1/2 on the bottom. I can remultiply each by its reciprocal, and I will find the x coordinate of the vertex to be a negative 4. Okay, how do I find the y coordinate of the vertex? I take and plug that negative 4 into the equation, and I will get 1/4 times negative 4 squared. Negative 4 squared is 16. 1/4 of 16 is 4, plus negative 4 times positive 2, that'll be a negative 16, and then plus 3, and I will find the y coordinate to be a negative 1. Okay, and so there's my vertex, and that is at negative 4, negative 1. So let's go plot that. Negative 4, negative 1. So here is my vertex. Now, what is the value of A? A is equal to 1/4. A is a positive number. We know that the parabola is going to open up, and we also have a dilation. So if I went over 1 originally, I would go up 1. Well, now I go up 1/4. So that's kind of an inconvenient point. What about 2? If I go over 2, normally I would go up 2 squared, so that's 4. Well, 4 times 1/4 is 1. So when I go over 2, I go up 1. Okay. What about 4? 4 squared is 16. If I went over 4, I would normally go up 16, but now I divide by 4, so I only go up 4, which gets me a point right there and a point right there. Okay, now let's pretend for, or let's not pretend, let's assume that that's a struggle for you. The other option is to say, what is y when x is equal to 0? And if I plug in 0 for my x value, I find that y is equal to 3 when x is equal to 0, and I can go and plot that and use symmetry to get my second plot to the left, okay? Now I have a equal, greater than or equal to, so I have a solid line, and this is what this would look like. And because it's greater than, I'm going to shade the region above the graph, okay? All right, next, y is greater than or equal to a third times the quantity x minus 4 times the quantity x plus 2. Hopefully you recognize the fact that this is in what form? This is in factored form. So we have x minus p times x minus q. And so we can quickly ascertain what the intercepts are. So x intercepts are at 4 comma negative 2. So we have 2 points on the graph. All right, where is my vertex? We need to find the x coordinate of the vertex, and that will be in the midpoint of that. So we'll take 4 plus a negative 2 and divide it by 2, and we will find the vertex, the x coordinate of the vertex to be 1. How do I find my y coordinate of that? I plug in 1 for my x values, and I will find that to be 1/3 times 1 minus 4 times 1 plus 2, and I will find my y coordinate to be equal to minus 3. So the vertex is now 1, negative 3. So let's go plot that, and we have that right here. Now let's evaluate A. A is greater than 0 because it's a third, so we know that our parabola is going to open upwards, okay? Now this particular, it has a dilation. It has a vertical dilation of 1/3, so we could use that information to graph, but it is difficult because it's a fraction of 1/3, but we also have our x-intercepts. What are our x-intercepts? That's the value of x when y is equal to 0. So let's just plot those x-intercepts. So x is equal to 4 and negative 2 when y is equal to 0. And even though we would like to have 2 points on each side of the vertex, 1 is enough. And by the way, I have greater than or equal to, and so it is a solid line. So do your best to have a, oh, that wasn't very good. So let's try it one more time. It's difficult on an iPad. All right, there we go. Now we have to decide which area to shade. It is shaded above because we have greater than. All right, why don't you try one yourself? Welcome back. Okay, so again, we are in factored form, and so I can quickly determine my x-intercepts. And the values of those are 4 comma 6. And if I have my x-intercept, I can find the x-coordinate of the vertex. And how do I do that? I find the midpoint between the two. So I add them together, divide by 2, and I find the value of the x-coordinate of the vertex to be a positive 5. How do I find my y-coordinate of the vertex? Well, then I take that 5 and I plug it into the equation, and I find the value of that equation when x is equal to 5. So 5 minus 4 times 5 minus 6, and I will find that to be a positive 3. So my vertex is located at the 5 comma 3. So let's go plot that. There it is. And let's take a look at A. We know that A is equal to negative 3, which is less than 0. Therefore, if it's negative, my parabola opens down. I have a vertical dilation of 3. It's also easy to ascertain, but I also have my x-intercepts. Let's go plot those x-intercepts. So I see that I have, whoops, I like to leave it as black. So I have a 6. Yep, 6 and a positive 4. But then let's also think about our dilation. So if I went over 1, normally I'd go down 1. This time I go over 1, I go down 3. And that's right at the location of my x-intercept. If I go over 2, normally I would go down 4, but in this case I would go down 12, and then that's off the graph. So this will have to do. It is does not have an equality, so this will be a dotted line. Okay, and then we have to shade, and since y is less than that, we will shade under the graph, and that will be my solution there. All right, I believe we have two more for today. And this is in, let me get to my notes. This is in vertex form, which is actually the easiest to graph. And so in that situation, if you recall, we have a times x minus h plus k, where the vertex is the coordinates of h, k. Okay, so in this situation, we can see quickly that the coordinates of the vertex is -2, comma, +4. Pay attention to this. Notice the standard form has -h. So if you have +2, you'd have to have a -2. So h is -2. Okay. All right. So let's go plot that vertex. That is x is -2, +4. We see that a is equal to -1, which is less than 0. So it opens down. And it is a -1. So we do not have a dilation. So every time I go over 1, I'm going to go down 1. Every time I go over 2, I'm going to go down 4. Same on the other side. Now I could also have picked a value of 0 for x, right? So if x is equal to 0, what is y? So 0 plus 2 is 2, 2 squared is 4, -4 plus 4 is 0. And so here is my y is equal to 0 when x is equal to 0. And then I could use symmetry to find my other location. I notice that I do not have an equality. Y is less than, so I have a dotted line. So I'd plot a dotted line through those points. That's not good. Let's do this. And since it's less than, I'm going to be under the curve. So I will shade under the curve. Okay. Last one. Why don't you try one yourself? I encourage you to use your dilations if possible. Welcome back. So this again is in our vertex form, and so we can quickly determine the coordinates of our vertex, which will be -2, -4. Okay, so go plot the vertex, -2, -4. I see that a is greater than 0, so I'm going to open upwards. I also see that a is a half. So instead of going over 1 up 1, I'm going to go over 1 up a half. Not the greatest point, but not too bad. Half I can deal with. If I go over 2 squared, I would normally gone up 4. This time I'm going to go up 2. Okay. I could have also found what is y when x is equal to 0? Well, 0 plus 2 is 2. 2 squared is 4. Half of 4 is 2. 2 minus 4 is -2. And sure enough, there's my y-intercept. It has an equality, so we will have a solid line. And we will get something that looks like this. And it is less than or equal to, so we will shade out below the curve. All right, I hope that lesson makes sense. As always, come see me if you have questions.